I have several videos already before I recorded this one on the AMCI SMD integrated stepper motor devices. I did one on Wireshark, which is relevant to finding the IP address on any Ethernet device. Just search Google Wireshark, download it, load it on your computer, and run it. And I demonstrate how to use it. I was impressed because I didn't have to read any instructions. So that allows you to identify what the Ethernet IP is on any Ethernet device, but in particular an SMD. Now, if it's brand new, it comes from the factory at the default 192.168.0 and 50. Then we also did a video that made first contact with these devices, meaning that once we knew the IP address and you can connect, you just need the IP address, type it in up in your field at the top of your browser, and it will open the web page on the device that you're connected to. Now, you can't have more than one at 50 connected at a time. So if you have 3 devices like I do and they're all at .50, you have to unplug 2 of them. Now, you don't have to unpower them. You don't have to power them down. You just have to pull the cable out from your switch. So you've got just one device at 192.168.0 and 50. And I show you how to do several things. You can change the IP address, subnet mask. You can select a different protocol. And if you think there's a newer firmware level, because on the very first page of the information, it'll show you what your current firmware level is. Now, if there's a newer firmware level and you want to go to that, you're going to have to call AMCI and get the password, and they will email you a file. If you don't have those two, then when you go to 192.168.0.50 and go to update firmware, you won't be able to enter a password to get to the next page where you select the file that you don't have. So make sure you do that first. Okay, in this video, we're going to do the bulk of the work, and that is I'm going to open up a connection to each of those SMDs one at a time. Now, in the meantime, I already went in and changed their Ethernet IPs to .40, .41, and .42. So one at a time, I went online with the web page built into them, and I changed the network configuration to not .50. You always want to reserve .50 for any new devices that you bring online. Kind of like they did with DeviceNet. They reserved 63 as the default address for new devices. So you did not assign anything to 63. So we don't assign anything to 192.168.0.50. That way it's always open. So in this video, we're going to connect with them one at a time, and we're going to manipulate them. That allows us to test out all the wiring and play with the configuration. And that will take a little bit more time than the other 2 videos while we're waiting for motion, because I'm going to have the camera focus on the fixture. So let's get right into this. I've opened AMCI Net Configurator. This is free software that you download from AMCI. Before you can use it, there has to be something to connect to. So in my case, I have the 3 SMDxxE2s that you see on the 3-axis fixture. I'm going to connect to them one at a time and manipulate them. The first thing I have to do is I have to pick one. So I scan. There they are, 40, 41, and 42. So I'll pick 40 first. It's the x-axis. That's at least what I'm calling it, the x-axis. I'm going to connect. I can see some information here, but I want to go to SMDxxE2 up here. I've got the dashboard open. Notice that it says disable power, which means that power is enabled. We're looking at the values of 4 words here. configuration word 0 and word 1 up here. I brought up this calculator. This is the Microsoft Windows calculator that is resident with the software. It opens as a standard calculator, but you can go to the selector up there, programmer. This allows you to select hex. Now you can represent hexadecimal values as binaries. Here's hex, decimal, octal, and binary, which means the one that's selected right here, the little blue bar there, you're going to select it or enter it in hex, but the others will display. Let's take this first one, 8406. Now I can convert that to binary in my head real quickly because you do it in 4 bits. This is 1000. This would be 0100. That would be 0000. This would be 0110. So let's try that out. 8406. See, there's the bit pattern right there. You also are displaying an octal and decimal. This is a handy little tool. You need to have it accessible. You can enter values. What this will help you do is in the manual, they show the function of each bit or what it represents in all of these words. We did the configuration word 0. There's configuration word 1. I'm not too interested in those, but down here, the status, this is your feedback. Here we've got 4408. 4 is 0100. 0 is all zeros, and 8 is 1000. So I can convert it, but it's still a handy tool. So we'll take this one here. Notice it's alternating between 8000 and 8800. But remember, this is hex, which that means these 4 positions can be 0 through 9, and as you see here, A through F. So that's 10, 11, 12, 13, 14, 15. I'll punch in 8000. Whoops, now it's taking the whole thing, so we'll clear all that. 8000. You can see it's just 1 bit on. I do believe that's the mode bit. So the mode bit, 1 is command and 0 is configuration, something like that. Now we'll clear that, and then we'll put in 8800. See, we have another 8 here. You would have to look in the manual to see what these mean, but if you're having problems, do this and go in the manual and look at what each bit in these status words represents. Now, because this is in a sense offline, in other words, this dashboard, or whatever you want to call this page, it's connected directly to the controller on the drive on the stepper motor. If I read the current configuration, it's in the command mode, it's going to be stopped. I can actually hear it click. Notice that nothing changed. So if I'm going to change input 1 configuration to home. In other words, I want this unit to believe that input 1 is for the home switch. Send configuration. Note, configuration accepted. Right now, I have the x-axis in the middle of its travel. If you look over at the device, you'll see that the x-axis, this stepper right here, is going to move this carriage back and forth. It carries the z-axis on the x-axis. So these two are mechanically entwined. This is the y-axis. It goes in and out. I have them marked clockwise, counterclockwise, counterclockwise, clockwise, and counterclockwise because I forget. In other words, I can't even remember if it's clockwise when you're looking at the face of the shaft or if you're looking from the motor out. So I have them marked based on how it responds. Now, your units are probably just laying on the bench plugged into Ethernet with power on them. I have an e-stop along with these over travel switches, 2 over travel switches on this axis, and you see one here and there's one back there you can't quite see. Those are all wired in series with the e-stop button. If any of those opens, it removes the main power from all of these units, but the aux power remains. As long as you have auxiliary power, you can still connect with the device and look at information. It just won't do anything because it needs main power. I'll make sure that this is e-stop's not twisted. So now I'm going to do a home. This axis right here, I want it to move this over here to hit this proc switch. That's the home. So I'm going to home clockwise. Now, one thing about homing, and this is kind of crude in the sense that you cannot select a separate speed for homing than moves. If you look up here on the screen, you see the velocity is at 2,000. That's what it's moving at, 2,000. The faster you move it to home, the longer it takes to complete home because it's going to stop and you watch it. You'll see a little move. And you see it back up. And now it's drifting really slowly. If you look at the screen, it says moving clockwise. Look at the screen, moving clockwise. At home, no. As soon as it stops moving, then you will be at home. Stopped, at home, yes. I don't want to go any further clockwise because then I will trip the over travel switch. One advantage to doing what you're doing, if you're following this, is it allows you to completely test out the electrical relevancy or to verify all the electrical on the devices and to manipulate them from this dashboard that's on the screen. Therefore, when you connect this up to the PLC, right now the PLC is completely disconnected. If you read the instructions on the previous screen, it said that these have to be removed from all other source of control. Otherwise, the other devices will take over. If I plug this into the PLC right now, it would take over and try to control it. They have to be disconnected. The only things that I have connected to this network are these 3 Ethernet interfaces to the drive to the motor. So I'm going to run it counterclockwise, which would be over to this end to see how many pulses I get travel from home to here. I think it's about 16,000. Let's do it. But I'm going to increase the speed first. You can see, looking at my, if you want to call it the worm gear for the shaft, that the coupling isn't really good. I mean, it's okay. It's close enough for what we're going to do. Okay, I kind of guess where to stop it. If you look up here, you'll see that I have just a little bit more space before I hit the over travel switch. That's close enough. You see we have 130,000. Look over here on the screen. Current position, encoder position. Notice they don't match. That just means they were both at 0 when we homed it. In the course of the load on the stepper motor, the encoder position is at 597. I'm skipping the bigger number. And current position is 606. But again, now we know that 130,000 is roughly the total number of pulses or positions, increments that we can use from home over to the other end. I'm going to go bring this back to the middle now. I'm going to go to 65,000, 90,000, 70,000. That's close enough. Basically 65,000. So now it's sitting right in the middle. Okay, we've checked all that out. I'm going to leave this unit. I click on Connect, which is the name of the screen, not the function. So we disconnect from that one. Now, read these instructions right here if you didn't already. Let's pick the other one, 41, which would be the y-axis. Connect. Go to the dashboard. I just heard it click. So the first thing we want to do is we want to home this. But see that it shows general purpose input up here. So if you try to home it, you're going to get an error. We want to home this counterclockwise. So I'm going to click on it and see we got an error. Press the reset errors button, check enable disable button if the driver is enabled. Well, that error, the text in that error is not correct. It's because I tried to go home, but I don't have an input configured for the home switch. So I'll reset the errors right here. Go up here, pick home, send configuration. Configuration accepted. Now I'm going to tell it to home counterclockwise. See, it's moving to the rear. And you can see that little button sticking out. When it hit the proc switch, you saw the proc switch light up. Now it's backing off, looking at your dashboard, moving counterclockwise. At home no. What it did is it hit the proc switch and then backed off, going clockwise, and now it's moving back counterclockwise at a really creep speed, called creep. It's sneaking up on the signal from the procs to get the best resolution. Okay, stopped at home. Now, because we home counterclockwise, we cannot go any further counterclockwise. But you see, the current position is 0, the encoder position is 0. It's right on the edge. It's kind of fluctuating. So now because we homed counterclockwise, we're going to go clockwise to see how much travel we have. In particular, you're looking right here to make sure that that guide doesn't hit the over travel switch. We can go at least another inch. Okay, looking up here, it looks like you've got 70. You could go 74,000. You might make it 72,000. Nothing wrong with 73,000. I don't know. I just like 2 or 4 better than 3. But anyway, so you got at least 72,000 pulses you can go in the Y direction. That's with this actually hooked up to the load, the application. Now, since we went clockwise, we're going to go manual back to 36,000. I'm just going to watch it here. Now, I use the immediate stop. Oh, I'm hit the home. Shoot. I wasn't paying any attention. Okay, that's something for you to pay attention to. I'm going to home counterclockwise to reset the home. Notice it did not lose the absolute position. Moving counterclockwise back towards the switch. When this goes out, you'll see the red light come on the procs. Okay, you see the procs, the home switch back here. See the red LED on? We know that we have, we'll run it out. Well, we have 70-some thousand, so I'll just manually go clockwise out to roughly 36,000. That's close enough. Now we've established total control over that device, the y-axis, and we know how many pulses we have to work with in our program. Let's click on the Connect tab, disconnect this one, scan, and grab 42. and connect. Now 42 is a very short travel. You can see here that the tool carriage that goes up and down, there's not much travel there, so you don't really need to put much speed in that. Let's knock the speed down to 500. And then you see here it says counterclockwise. We're going to home to this switch counterclockwise. Guess what I forgot to do? I forgot to set input 1 configuration to home. Now we can home counterclockwise. I had to kind of reform the lever on this switch because this ran out of travel before it completely closed the switch. That's what happens when the switch doesn't close. Let's try that again. I probably could take and move the bracket on this switch into a better position. It's right on the edge. I'm going to send the configuration again to make sure that it knows that that's supposed to be home. I know we did it. The only thing I can think of is that the switch didn't close because it hit the end of travel, the hard end of travel, before it actually hit the switch. So now I'm manually going to go clockwise. Now we're going to try that again. So we're going to home counterclockwise. Okay, you see it hit the home switch, it stopped, and then it backed off. Now it's creeping counterclockwise. Look at the dashboard, moving counterclockwise, at home no. And no matter what the information is over here, current position, encoder position, you'll see it go to 0 as soon as it's at home. Moving counterclockwise, at home no. Stopped. At home, yes, 0, 0, 0. Now, in my little application here, this is kind of crude, and these are single pole switches. So my over travel switches are all little single pole micro switches. I have no real way to feed that into the PLC that knows what over travel was tripped. I could create some logic that says if it's going clockwise, but see, you don't know which axes tripped it because they're all wired in series. In a real application, you would probably feed the individual switches back to the PLC, then you would have an output from the PLC act as the e-stop. And you can set up one of these inputs to be emergency stop. That's probably a good solution. I like hardwired myself personally, old school. Anyway, I think we've kind of exhausted what we can do with this dashboard. Now there's all kinds of other things here. Maybe we'll come back and do another episode where we do some motion test. But for now, thank you for watching. Favor go with you when you're working with this stuff. Thank you.